In this video, we're going to look at radical equations. Something radical can happen with radical equations, so pay careful attention. As always, let's start by defining what it is that we're going to talk about. A radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. We solve radical equations with nth roots by raising both sides of the equation to the nth power. As always, I'm going to give you an algorithm that is my way of working these equations. And this one has a critical step in it, so please don't skip it. But here you go. If necessary, arrange the terms so that one radical is isolated on one side of the equation. If there are multiple radicals, I don't care what happens on the other side of the equation, but make sure one side of the equation has only one radical. Then raise both sides of the equation to the nth power to eliminate the isolated nth root. If it's a square root, raise it to the square power. A cube root, raise to the cube power, etc. Then solve the resulting equation. If that resulting equation still contains radicals, go back to step 1 and repeat steps 1 and 2 until all radicals are removed from the equation. Now for the critical step that you cannot skip. Check all proposed solutions in the original equation. And it's critical because you may have twice as many solutions than what actually exists. So there's no skipping this to save time on this video. We will check every solution, and as we do, you'll see why it is so critical. So here we go with our first example. I have a radical equation because I have an x under the radical. It doesn't matter that this one's not under a radical. What matters is that this one is. And since it is under the radical, I have a radical equation. So I want to use my algorithm for solving radical equations, which says isolate the radical. So I want to get x plus square root of x plus 3 on a side by himself, which means I've got to move this other plus 3. Well, since he's plus 3 on the left, he's minus 3 on the right. Now my radical with the x underneath it is on a side by itself, so I am ready to raise both sides, in this case to the understood 2 second power. Okay? So I'm going to, and I'm going to write it right here so that I don't waste your time on this video. Instead of rewriting the whole thing, I'm just going to show you that I'm raising this to the second power. Okay, so the square and the square root sort of kind of halfway cancel each other out, leaving the x plus 3. On this side, I'm going to use my formula that says front guy squared, minus sign, 2 times front times back, so 2 times x times 3 is 6x, plus back squared, 3 squared is 9. Now I'm down to a quadratic equation that I think I know how to solve by now. So I want to set it equal to 0. That was my algorithm for quadratics also. So that would be x squared. Since it's plus x, I'm going to say minus x. That'll give me minus 7 altogether. Since it was plus 3, I'm going to say minus 3, and that will leave me 6. This guy can factor because I'm thinking up here, factors of 6. Both signs negative that add together to give me 7. So this is going to be x minus 1 and x minus 6. If I wanted to solve a quadratic formula, could I? Yes, you could, but it's going to take you a while. All right, so I've got 2 guys multiplied together to give me 0. So one of those 2 guys has got to be 0. So x is either 1 or 6. Could possibly be both, just not at the same time. Okay, now, Miss Harrell said, don't you dare skip checking on this one. It could be that x is 1, it could be that x is 6, and it could be that x is neither one. The only way I know is to check. So I'm going to check my 1 first. 1 plus 3 plus 3 equals 1. And then 1 plus 3 is 4, so the square root of 4 plus 3 equals 1. Square root of 4 is 2, but 2 plus 3 does not equal 1. If I could take the negative 2, could I force this to work? Yes, but you can't take the negative 2. This symbol, which was part of my problem, says the principal square root, which is positive 2. So this guy does not work, and I throw him out of my answers. And now I check the 6, wondering if he's going to work or not. So plug in a 6 for x, that's 6 plus 3 under the radical, then plus 3 equals 6. 6 plus 3 is 9. Square root of 9 is 3. And 3 plus 3 is 6, so he's going to work. So I had the possibility of 2 answers, but only 1 worked. This is why that check, I tell you, is so critical in radical equations. For the second example, we're going to work an equation that looks very, very similar to the first, but that's going to be worked slightly differently because of the resulting quadratic. So let's take a look at this guy. Again, he's a radical equation because he has an x underneath the radical. So step number 1 is going to be to isolate that. So I want to isolate the square root of 2x minus 1, which means I've got to move the 2 to the right-hand side, making him a minus 2 instead of a plus 2. Then, exactly as before, I'm ready to raise this to the power of the index, which is, again, the understood 2, square root, square power. On the left-hand side, that leaves me with my radicand, the number under the radical. On the right-hand side, I am using my formula for squares. So that's going to be 2 times 2x, which is 4x, plus 2 squared, which is 4. This is a quadratic, so I want to start out by setting it equal to 0. I'm going to say minus 2x, and 4x squared minus 2x is minus 6x. And since it's minus 1, I want to say plus 1. That would be plus 5. Now, yes, I could do this one by factoring, but I also want to show you an example of doing it by completing the square just because we can. It's 1 and even. It's kind of simple. I'm going to move the 5 over here and make it negative 5. I'm going to leave room for plus some number. And this will leave me with x squared minus 6x plus that same number. Now to complete the square here, I need half of that guy. Half of 6 is 3. To fill in the blanks, 3's got to pass through the square, so I'm going to be adding 9 to both sides. Negative 5 and 9 is 4. Then I'm going to take the square root of both sides. The square root of 4 is positive or negative 2. I'm not sure which. And this is x minus 3. So now I'm going to add 3 to both sides. And here's why I wanted to get to this. A lot of times students get here and don't know what to do. This is a plus or minus. That means you're going to take it both ways. So 3 plus 2, I have a possibility of 5. And 3 minus 2, I have a possibility of 1. So again, I have 2 possible answers, and I need to check them out because odds are one of them at least is not going to work. So I'm going to try the 5 first because he's listed first. 2 times 5 minus 1, and then it's plus 2 equals x, which I'm thinking might be 5. Okay, 2 times 5 is 10, minus 1 is 9. Square root of 9 is 3. 3 plus 2 does equal 5. So the 5 checks out. Let's check the 1. I'm really kind of halfway expecting him not to work. 2 times 1 minus 1 plus 2 equals 1. 2 times 1 is 2. Minus 1 is 1. Square root of 1 is 1. but 1 plus 2 is not 1. So the 1 gets thrown out, and again, I have only one solution, 5. It is possible to have them both work, and it is possible to have no solution. So check every answer. Let's do one more question before we go. This is the nasty one. What happens when I have more than one radical? And this really does happen, so I do want to work through it. Well, since that's a minus and I like things to be positive, I'm going to move him to the other side. I'm going to isolate the square root of 3x plus 1. I'm just isolating a radical. It does not matter which one. But I'm going to isolate one radical, and then I'm going to square both sides because it's a square root. So I'm going to square both sides. Okay. That'll leave me with 3x plus 1, maybe. And I've got to use my formula over here again. So this is 1 squared plus 2 times 1 times square root of x plus 4 plus square root of x plus 4 squared, which is just x plus 4. Now I got a little simplification to do before I can do anything else. 1 plus 4 is 5, so this is 2 square roots of x plus 4 plus x plus 5. Now I need to isolate the x plus 4, the square root of x plus 4. So I'm going to subtract x from both sides. I'm going to subtract 5 from both sides. Then I'm going to divide everything by 2. That leaves me with x minus 2 equals square root of x plus 4. Now, again, I'm ready for my second time through squaring both sides. And again, I'm going to use my formula. X squared minus 2 times x is 2x, double it, that's 4x, plus 2 squared is 4. And my radicand is x plus 4. So I'm going to subtract x from both sides. And 4 minus 4, oh, that's 0. That's nice. Now I can factor this easier. Take out a greatest common factor. And he's completely factored. So x is 0, or x minus 5 is 0, in which case x is 5. Now, I've got to check them out. So I come back to the initial one and I start with 0. Simply because 0 is my first listed answer. And I get 3 times 0 is 0, so this is square root of 1 minus this is square root of 4. I get 1 minus 2 equals 1. Not true. So 0 is out. So let's try 5. It's going to be 3 times 5 plus 1 minus 5 plus 4 equals 1. So this is square root of 16 minus square root of 9 equals 1. This is 4 minus 3 equals 1. He checks. So my solution is 5. Again, the important thing about this, number 1, get the process down. But number 2, never neglect the check.